If you are preparing for AP Chemistry, DAT, or MCAT exams, you have probably been told to memorize more chemistry, more reactions, more formulas, more rules. Very few people stop to ask whether this is actually how chemistry should be learned. Today, I want to show, not just tell, why memorization quietly damages your thinking in chemistry. Memorization feels safe because it gives certainty. You either remember something or you don't. But AP, DAT, and MCAT rarely reward certainty first. They present unfamiliar situations and puts you in the unexpected circumstances and observe what your thinking does next. So we need to better prepare for unfamiliar situations. Let me show you exactly what I mean using one of the most common topics students think they know very well: buffer systems. Most students memorize one sentence about buffers, that buffers resist change in pH. That statement, that sentence is correct, but it is not understanding, because many of us knew this fact, but very few of us know how does it resist the change in pH. Let's understand with some examples. For example, if I take an acidic buffer, let's say CH3COOH plus its conjugate base, acetate ion, sodium acetate. Now, what will happen if I add a slight amount of acid into this mixture? A memorizing student immediately asks, which formula do I use? Is this something related to Henderson-Hasselbalch equation? Whereas a reasoning student asks a different question: what happens to the added H plus? What is the fate of acid now that we have added into this acidic buffer? Adding a strong acid to an acidic buffer causes the added H plus to react with the conjugate base. Once you knew this concept, you can easily answer the situation that this conjugate base of this acidic buffer immediately reacts with this added H plus ion, forming more weak acid. It will form more weak acid, which results in only a very slight decrease in the pH of the solution rather than a significant drop. All right. Because once you understand that buffers works by consuming added acids or base through equilibrium reactions, the question stops being about recall. And this is how actually we need to answer this particular question, right? It becomes something you can predict even when the numbers, concentrations, or biologically context changes. Now the question is why this all matters for AP, DAT, or MCAT exams. Why this level of understanding we need for these exams. Let us talk about that. AP chemistry checks whether your understanding is internally sound, whether your basics are actually clear. So AP actually tests conceptual clarity. DAT chemistry checks whether you can reason, without being uh, freezing under time pressure. So you have to be prepared for reasoning within time. It's a time bound exam. You have to perform within time. On the similar lines, MCAT chemistry checks whether buffers still make sense when they appear inside blood, cells, or enzymes. In short, it checks chemistry inside biology. Memorization survives none of these situations. In chemistry, formulas describe outcomes, not thought processes. If students begin with formulas, they begin after the reasoning has already happened. ChemReason exists to build chemistry from its logical core before memorization interferes with the understanding. If this way of thinking feels unfamiliar, this is exactly why it matters.